Hello everyone. Good evening.
Good evening, sir.
Okay. So how many participants are there? Okay, only 16. So we will be start in 8, 10. Okay.
Sure, sir.
Okay.
Sir, what will we discuss in today's section?
Uh, you have any doubt in week 4 content? So we will discuss that thing.
Yes, sir. I have some doubts.
Yeah. Okay. So you guys have any parallel classes or this is the only class?
So I think CT session was going on.
What?
The CT session is going on, I think,
Okay.
6 to 8 p.m. I mean.
Okay. We will wait. What is the session?
So, computational thinking session. It's a live session. That's still continuing.
Okay. So is this instructor session or TA session?
So, it's taken by POD.
Okay. Okay, so can we start?
Yes, sir.
Okay, so you guys have any doubts, or otherwise we can discuss the portion of this week.
Sir, I have a doubt from PYQ. Sir, can you sir discuss at the end of the session?
Yeah,
Okay, sir.
so you guys want to revise revision of this week?
Yes, sir.
Okay.
Sir, I had doubt in the graded assignment question of week 3, last question, that 10 point and 40 point, that question.
Okay, which question?
Graded assignment of week 3, last question.
Let me see.
Is it the one in which it says that converted to 10 scale?
Yes, sir, that question only.
Okay. Okay. This one. This one.
Yes, sir, that same question.
Okay.
No, the last question of graded assignment.
This one is the
It's
last
the
greatest assignment, no?
Sir, the
for
question
question. What is
easily
question number
shuffled.
9?
Okay, okay.
Not in
What
same.
is
Everyone is
question 9? Yes, question number 9. Question
Yeah,
9.
I already discussed this in last that solve with us session. See, your marks are from 100 in this data. Can you see this cursor?
Yes, sir.
Yeah, so the student marks are from 100 out of 100. Then they get 45, 47, 55, 62, 73, 77, 78, and 79. Now that question ask me about mean. Okay.
Median rating.
Yeah, median rating. Okay. So median and convert it to 40 points. So see like this. So if your rating is from 100, then your median is let X. Let me use this pen and paper. Okay. Just a second. Okay. Okay. Yeah. So see. So if rating from 100, assume that your median is assume like 50. Okay. Assume
Yes,
this is
sir.
the now question tell me about rating from 40. This means when we count rating from 100, then we get 50. If I count rating from 1, then what I get? 50
One
divided by 100.
Half.
Okay.
Yes,
Now
sir.
if I count rating from 40, then what the answer?
20.
Okay. 20. So is this the answer?
Okay, so whatever will be the median after adding 1 point, we will take the 40% of that.
Yeah. Is the I think you learn this thing in it's the see when there is one in childhood there are question where 100 toffees are in 50, then cost of one toffee, that type of question, you know.
Yes, sir. Now
Yeah,
it's
same thing,
clear.
same thing, same thing. Okay.
Unitary
Okay.
method type.
Yeah. So any other doubt? from last week?
Yes, sir, that previous question of this eighth question that we're showing in graded assignment.
Okay, this one.
They're not showing a screen.
The eighth one.
Yes, sir, eighth one. That average cards number 1 to 21. That
Average card.
card numbered from 1 to 21. That question, sir. Numbered question, card numbered, find mean and that mode.
Yeah, it's 1 to 40 question. And card number 1 to 40.
Yes, sir. What in me it's written 1 to 20, sir.
In your question, it's written 20.
Yes, sir.
Okay.
So I did not understand that question.
Okay. So there are card in a deck. There are card number 1 to 50.
In the deck card numbered from that question, sir.
Yeah. Number of cards in the particular number in the deck is the same as the number of cards. So in a deck there are cards.
So your another screen is not visible.
Which one?
We are able to
Okay,
see
okay.
this PDF screen only.
Okay, sorry. A second. Sure. Now,
Yes, sir. Now it's visual.
okay. So
Yes,
in a number such that the number of cards of the particular number in the deck is the same as the number of cards. Okay. So which of the following statements are true about mean and median? So see.
Yes,
so there are cards in which they numbered as 1, 2, 3, 4, 5 and 40. Okay.
Yes.
And there are 1 card of 1 number, 2 card of 2 number, 3 card of 3 number.
Yes, sir.
Like this. Okay.
We will add all 40 number and divide by 40 for mean.
No, not 40. Now total number of card. Okay. Mode of the number of the card on this deck of card. So now you have total number of card. How much?
40 cards, sir.
No, not 40, bro. See. Let me.
There are cards numbered from 1 to 40, such that number of cards of particular number in the deck is same as the
Is the
following.
same as the number of card.
Yes, sir.
It means if card number is 2. Okay. So
Yes,
there
sir.
are 2 card of 2 number.
Okay, sir. Like that.
Yeah.
Oh.
Now you can solve.
Yes, sir. I will try again.
Okay.
Sir, I have a question. So I solved this thing. In this, so if we take out the sum of the number of the cards, then we'll find that there are around 780 cards.
Okay.
So how will the mean be 27 if you if you take a how will the mean be 27 if there are 7?
Sir, it's like that, sir.
What?
Sir, I'm asking that I will do that like that. There are card number 2, then 2 plus 2 is
Yeah.
then again card number 3, 3 plus 3 plus 3 means 9.
Yeah.
Like that, no, sir?
Yeah.
We keep on squaring and cubing like that. 40 is raised to the power 40 again.
Yeah. Same.
Okay, sir.
So you got answer or not?
No, sir, I will solve, sir.
Yeah. So answer. What is the answer?
I will solve, sir, later.
Okay. Sorry.
Sir,
Sir,
in this
if
question,
it's
I use
possible,
the
then can you
Google
solve
Sheet.
this question?
Yeah.
Sir, in this question, I use the Google Sheet approach, means filters, values, and the multiplication, all the things. But is it there's some formula to shorten this?
Yeah. We have formula.
Okay. Could you highlight which one, please?
Yeah. Just a second. How to multiple screen? Just a second. Okay.
Sir, calculation of the sum of the bill we
Yeah.
can have.
So you have 1 card of 1 number,
Yes, sir.
2 card of 2 number, 3 card of 3 number, like this.
Squaring, squaring, yes, sir.
Yeah, so we can square this. So 1 plus 2 square
Square plus
plus
3 cube.
3 square. Oh,
Cube,
sorry.
sir. 3 cube.
No. Just a sec.
3 plus 3 plus 3. 3 cube.
3. No. 3 plus 3 plus 3. So take common as 3 and 1 plus 1 plus 1. What is
Yes, right. Yes,
3
sir.
square? Yeah,
Yes, sir.
just a second.
Right, sir.
Yeah. 3 square plus 4 square like this. How much? 40 square.
50 square.
Yeah. Now divided by what?
1
Summation
plus
of
2 plus summation
1
1
plus 2
40.
plus 3 plus dot like 40.
Yes, sir.
So you know this sum,
n into n plus 1 in the bracket
n
n plus
into
1
n plus
plus 2
1
by 2.
2n plus
1, I think.
divided by 6.
3. 6, yes.
Yeah. And this sum is what?
This sum
n
is,
n plus 1 divided by 2.
Summation n.
yes, sir.
So just solve. Put n equal to be 40.
Yes, sir.
Yeah.
Right. Thank you, sir.
We can cancel out n plus 1
Yeah, we
directly.
can answer. You can solve by yourself. Okay.
Yes, sir.
Yeah.
So just a small doubt. So the 1 plus 2 square plus 3 square, is that a geometric progression?
No.
Okay.
Geometric progression is like
Sir.
this. R square, R cube, like this. Okay.
The numerator one is
Yes,
summation n square.
Sum of AP.
Yeah, numerator is AP, but this one is not it. This one is, we have formula. This one is the formula. Just use formula.
Yes, sir. Binomials, from binomial we can reduce this
Yeah,
formula.
yeah. And okay. So anyone know how to share multiple screen? I forgot.
Sir, in this formula, what we have in denominator?
What?
What we have in denominator in this formula?
Sir, for enabling multiple screen sharing, I mean, you are asking the participants to share screen, or you want to share multiple screens, sir?
I want to. No.
Sir,
You
by
can.
split the screen.
Excuse me, sir. Hello.
Yeah.
Sorry for disturbing class, sir. Sir, I have doubt, sir.
Okay. Just a second. First, I explain this one. Okay. So, yeah. So we have in like this n plus 1, 2n plus 1 by 6 divided by n plus 1 divided by 2. Just solve this and you got the answer. Okay. Yeah. Your doubt. What's your doubt?
Sir, I am selecting city preference Allahabad, Uttar Pradesh, sir, but my dashboard is shows Odisha and Chhattisgarh, Raipur. How to change, sir?
I don't know, bro.
After 4 or 5 days ago, hall ticket was released. I can't go, sir, Chhattisgarh and Odisha also.
I think there is a glitch in the qualifier. There is my center is shown Mumbai, but after some time it changed.
Okay. So just write mail to administration. I don't know this kind of stuff. Sorry for
Okay,
that.
sir.
Okay.
Sir, how many questions will be there in the qualifier exam?
I don't know. Sorry. I have no idea. I am recently joined the team, so
I think, sir, there is a 11 to 15 question in the qualifier exam.
okay. But it doesn't matter if you know. There is no problem.
Sir, there are
And
13 to
what
15
about
questions.
and what about the tutorial of week 1 and 2? Will there be questions from that too?
No.
Oh, sorry, I don't
No,
know
no.
these things. If anyone know,
No.
that guy can explain.
नहीं होंगे sir.
Okay.
Hello, sir. Sorry to interrupt. But, sir, can you help me with question number 6?
in this assignment?
Yes, sir.
Okay, this one.
Yes, sir.
So what's the problem?
Sir, my answer is 77.
Okay. So anyone solve this problem or
Yes, sir, solved.
okay? So what's the
You
answer?
have to first calculate 25th percentile, then 75th percentile.
Yeah, I know what's the answer.
Sir, I'm telling that
Yeah, what's the answer?
answer is 55 only, sir.
Yeah, so maybe you did wrong calculation. Try again. Just
Sir,
5,
but
12. Yeah.
it is accepted answer is sir 76.
Accepted answer is I 55, no?
Okay, sorry, sir. You have different data. I have sir different data.
Okay.
Okay, I sir tried solving 75th percentile minus 25th percentile.
Yeah.
In my data. Then
Yeah.
this answer came 0.25 into sir my 25th percentile means third observation.
25. Okay. We have 10 data. Okay. Let me 25. Okay, 10. Yeah, third observation.
But sir, I have odd number 9 data.
Okay, then it's also I think third observation is 2 point something, no?
Yes, sir, 2.25.
Yeah, so that is also
2.25.
that is
And
also
we
third
have to
observation.
arrange also, sir, in ascending
Yeah,
order.
in ascending order you have to arrange in ascending order, then see the position.
Sir, I have arranged it in the ascending order.
Yeah. Okay.
Sir,
Yeah.
for IQ, for finding IQ also we should have to arrange in ascending order, no, sir.
What?
We have to arrange this in ascending order, na?
Yeah, yeah. Okay, that guy. Yeah, you can continue.
Sir, the sir, 25th 25th percentile is the
Percentile is third observation.
and 75th is 8th observation.
Okay.
So, sir, I am getting the answer 77, one short of 76
Okay.
in my data.
Okay.
Sometimes we have to take average also when we are getting exact like 2 or 3 integer values. Like that.
Okay, sir. For odd one, it's +1.
That you can just solve by this percentage method, no? Why you solving by +1 and -1?
Sir, can you bit
Okay.
explain?
Yeah. See, let me say this. Now you can see the screen.
Yes, sir.
Okay. So see, let P is your percentile. Assume that it's 25, then value 25, then value of P is what? 0.25.
Yes, sir.
Then find NP. Okay. Then assume that it's something like if n is 10, then it's 2.5. If n is 10, then it is 2.5. Then see the third value. Okay. Yeah. Like if it is 1.7, then see the third value. If it is 1. No, sorry,
If it is
second
true,
value.
sir.
Second value. And if it is 1.3, then also see the second value. Okay. Just by doing this,
Okay,
you can
sir.
get the that percentile.
Sir, for 2.25, it's 3.
Yeah. 2.25 also 3.
Okay, sir. So I have to take third observation.
Yeah.
Sir, I have doubt in question number 3 of that assignment, graded assignment.
Okay. Question number what?
3.
3. So what's the problem?
That's a mean and sample standard deviations are given. and later it is noted that one observation 40 is wrongly noted as 11. What is the sample variance of the original data set?
Yeah, I already discussed this question in
That
Solve
part,
with Us.
sir, second equation I don't able to get. I'm not able to get that second equation, a standard deviation one equation.
This one, second one.
Sir, slide is not visible, sir. That slide.
Okay, sorry. Okay, just a second. I have to share full window. See. Okay, check. Okay, now you can see.
Yes, sir.
Okay, so which one? This one? Third?
Third one observation is sample variance data.
Yeah, it's wrongly
yes,
connected.
This one. Then
This
second equation I am not able to get, sir. How to make second equation in terms of x and y?
Second equation in terms of x and y?
No, x. I means to say that mean I can understand how to calculate the new mean. But
Okay.
new standard deviation I am not able to get how to get that.
So, okay. You are in last class or not?
No, sir, I was not in last class.
Okay, let me open that slides. Okay. There, I already discussed this question.
Okay, sir, then leave.
Or either you can watch the live lecture.
I can watch the recorded. Okay, sir.
Okay.
Okay, sir.
Hello.
Yeah.
Sir, give me a relation between sample variance and population variance. There is a question, but I don't even remember where I see. Sample variance is given and population variance.
Okay.
Relation
Sample.
between.
Okay. So what is the? Just a second.
In practice assignment, there is a question week 3.
Oh. In practice assignment, where?
In first.
This one?
Yes, sir.
Which question?
There is a question, but I don't remember where I see.
Okay.
Sample variance is given and n is given. Find the population variance.
Sample variance is given and what is given?
N number of observation.
Okay.
And then it is saying that find population variance.
And it okay. And it also gave that in sample. How can this possible? Value of n is same for sample and population same. Is this given?
Yes, sir. Yes, sir.
Okay. So see, if n and n is equal, is this given? This is sample number of sample, or this is number of observation in population. They are same in that question.
Yes, sir.
Okay, so see, what is the formula for sample mean? Xi minus x bar. This?
Yes, sir.
And what is the formula for population mean?
Capital N, yeah.
1 by n summation xi minus x bar square.
Okay, this. So just do what? Either divide, multiply and divide by n. Okay. Now what you get? You
तो
get
फिर तो सेम ही आंसर आ जाएगा.
why? Now you are using this n before. See, assume that in your population 10 observation. Okay. So in formula of sample variance, you use this 9 and then the expression. But in the expression of population,
variance
you
is-
use this. So for answer is different, na? I am giving a relation. So relation is this. N divided by n minus 1. This is the population variance. Okay. This is the sample variance. Okay.
Yeah, something like that I got from the ChatGPT.
Yeah. I think
Population
this is the
variance is
relation. If n and n are equal. Otherwise, I don't
Yes.
know. Yeah.
Thank you, sir.
Okay. Any other doubt?
Sir, week 4, let's start week 4 discussion.
Okay, just a second. So week 4 started from this one. So
Today week 4, no, sir.
What?
Today we will discuss week 4, no?
Yeah.
Okay, sir.
Okay, so we already learned how much things, how much tools we have. We know descriptive statistics, inferential. Okay. Then in second week we learn about this is the first identify cases and variable. Okay.
Yes.
Yeah. After that, in second week, I think we have classified the variables or category and numerical, and after that we find measure about these two type of data, that nominal, ordinal, interval, ratio. Okay. Then after finding this, we make some measurement things about how to relate the data, how to get information from data. For that, we have sequence table and relative sequence table. Okay. This one for what? This is for categorical data. Okay. After that, we have pie chart and bar chart for categorical data. After that, we have mode and median. Okay. Then we, in third week, we have that continuous numerical. We find measure about the continuous data. So we have what? Frequency table. After that, which we after that we have mean, median, and mode. And then we found which is the measure of central tendency, which give the center part of your data. Okay. Then we have measure of dispersion, which give you how much variation you have. Okay. And then we learn percentile, quantile, and interquartile. Okay. Now we have fourth week. Okay. So in fourth week, so in this ways we want to relate our datas like categorical and categorical, numerical, and categorical numerical. Okay. So firstly we see the how to relate categorical data to categorical data. So for that we have contingency table. Okay, for two categorical variable. So after that we have what we have. Yeah. This one is okay. Now we learn in summarizing two categorical data, we have what? Contingency table, where we got notion about what? Row frequency and column frequency. Okay. These are our main point to relate to categorical data. Okay.
Okay, sir.
Yeah. So now see how to relate. So we have some content. Yeah, this is the table. So we want to observe about how to gender is related to the person have phone or not. Okay. So for that we have some observation of 100 people. So firstly we say how much female we have. 44. How much male we have. Then we observe how much female have phones, smartphones, and how much not have smartphone and how much have. Like this we create one table. Okay, which gives what information we can generate from this table. See, if I say just yeah, it's I say the we have in 124 people have no phones. Okay, no phones. Then there is two part. One is how much females have no phones and how much male have phone. Okay, so we have 10 females who have no smartphone and 14. Like this we can observe the data. Another sense, if I say we have 44 female in our data, now we can generate question about what, how much female have smartphone and how much have no not. Okay, these type of question I can easily found this by this table. Okay, so now we have one another data, which is what, yeah, see. So now we have level of income. One is high, medium, low, and we want to know is income depends the user have phone or not, or you can say is user have phone or not is depend on income or not. So we have 100 people data, out of which uh, 20 have high income, 66 have median, and 14 have low income. Okay, and then I can ask question about what, how much high income people have phone and have not phone. Similarly like this, and another question which I can generate what, I have uh, 38 observation where who have no smartphone. Okay, so I can generate how much uh, like this is 38 are our observation. Then I can say out of 38, those who have no phone, 2 are coming from high income, 27 are coming from low median, and 9 are coming from low income. So like this we can summarize our data with respect to one, with respect to two different variable. One is what, smartphone owner, and what is another is income level. Okay, now we have for that we have two frequencies. One is row frequency and another is column frequency. Till now anything any doubt or
No, sir, it is clear, sir.
okay, now we have just so first lecture, then how to move. Okay, just a second, give me a second. Shit, one second, how to, one second. Lecture 3. Okay, let's see. So yeah, are you able to see the slide?
Little bit zoom in, sir.
Okay, I didn't. Now?
Yeah. Okay.
Okay.
Yes, sir.
Okay. Now we have two frequencies. One is row frequency and another is column frequency. So now we have question about what is the proportion of total participant on the smartphone. So we have table like this. See, I think there is one more slide. More. No. Just second. Just second. Just second. This one is what? This one 40. Okay, this one is this one. Okay. Now let's start. Yeah. So we have frequencies. Now I can generate some question from this data. So this is the frequency table. Now we can create a row relative frequency table, which is this. Yeah. This. See, 44. Why this is not okay? Divided by 100, 4. Okay. We have 44 females, out of which, if I ask how many female own the smartphone, so what's the proportion of female who own the smartphone is what? 77.27. So see, this is the condition which I impose, that I am asking about female, and then I am asking about how many females own the phone, the proportion of females own the. So my constraint is what? Female. If I ask how many men own the phone, then answer is this. But if I change the context, that I have 77% user who own the smartphone. Okay. But if
Yes, sir.
I ask how many female okay, if I ask, if I have 76 observation who own the smartphone, am I asking about how many of them are female, and what is the proportion of female? Then what's the answer? 34 divided by what?
44.
Why 44?
Sorry, 76. I think
76.
the column relative frequency.
So this one is column relative frequency, where
Okay, sir.
I gave you information about what? User of smartphone. Then I'm asking about gender. Okay. But in row relative, I gave information about what? Gender. Then I'm asking about smartphone. You can see the change. How the context change. So by this contingency table, I can summarize using using one variable. I can summarize another, and okay, my bad. Using one variable, I can summarize V2, and using V2, I can summarize V1. Okay. If this is summarized by row frequency, then this is by column. Okay. Okay. Any doubt?
No, sir.
sir.
Okay. So now we have what? Now for that, now we have how much association is, how much the variable are associated. There is one question. Between two variable. Yeah. So what is the main? Yeah, you can read this slide. Now, how much these variable are related? So for that, what is the rule? If the row related frequency of one variable, this is the one variable and this is the second variable. Sorry, one variable, one type of observation and second type of observation of one variable. So if the row frequency are the same for all rows, see here I have 22 and here I have 25, not much difference. Here I have 77, here I have 75. So these two have same frequency, almost same. Okay. So they are not associated with the another variable. Like I can't say that smartphone owner is describe the either that person is female or not. Okay. Like this, if I see in this column, see I have 22. Okay, just a second. Firstly, I remove. Okay. See now, this is the row. Now I have column related frequencies. Yeah, these are the column related frequencies. Okay. So if I compare it, this is the 44, 41, and this is the 44. Not much difference. Same here. So if this is the condition that row relative frequency are same for all rows or column relative frequency are same for all column, then these variable are not associated. I can't say that one variable depends on other or changes other variable, or yeah. And if okay, now we have another data that high and medium got. So here I have, this one is row related frequency and this one is column related frequency. See, this observation, this all are different. Here you can say there is no, not all, they are not almost, even not almost same. Huge difference between 10 to 40, 64, like this. So there is no, all row relative frequencies are different. Similarly, if you see the column relative frequency, this one is 5 and this one is 29, 71, 62, 23. So huge gap between these frequencies. So these data are not these data are associated with the each other. I can say that smartphone user depend upon the income, or income depend on the vice versa. Income depends on smartphone user. Now we have one stack bar chart.
Excuse me, sir.
Yeah.
Sir, I have a doubt, sir. When variable are not associated, at that time row relative frequency and column relative frequency are not same. Sir, can you give any range if the difference between the two variables are lie in that range? It means they are as they are not associated. I want to. I mean, in the when variables are associated and where variables are not associated, in both cases value the difference between are not same for all the variables. So sir, can you give any range, because sir, it helps during the sir exam. So if
It's
data
by
lie in
intuition.
that range, it means
See this example, you can see easily that these values are very near. Only difference is 3. Here we have difference of 2. Similarly, if you see this one, here difference is what? 3 and here 3. But in this example, difference of 30. So it's by intuition. If values are very near, and I don't know what's the exact bound, but yeah, you can
So,
yeah,
sir, can I conclude that if the difference between is less than 5, so
yeah,
we
you
can
can
say
conclude.
variable are not associated?
Yeah, or if
Okay, okay, sir.
see, if the if let's see, just a second. See, if difference between this and this is assumed that 5, and difference between this and this is also a constant term, like between 5 and like 5
4,
and 4 3, like this, then you can say.
yes, sir.
But if difference between this and this is 10, then you can't say.
Okay,
So
okay, sir.
it's like intuition, or
Okay, sir. Thank you, sir.
maybe there is some relation. I don't know exactly, but yeah.
So could you also highlight this point that you said that if this relative frequency are like there is a on the condition when there is a relation, and on the condition there is a not relation based on this relative frequencies.
Yeah. So what?
Could you highlight that point again? Like how to see that with the from the relative frequency
Okay.
table that is this a relationship or not?
Okay. See, now in this example, see, I have 44 females, out of which those who have no smartphone, that proportion is this, and those who have smartphone, that proportion is 77. And if that person is male, the proportion is same. So is this depends on gender? No. How do you
So
relate this? Yeah.
well, like if we see that if we have that of the total 77.27% owns a smartphone, then we definitely know that 22.73% definitely
Yeah.
does not.
Yeah.
So
Yeah. This
they
is yeah.
so
But
in that sense they are related. But
yeah.
like you are saying that I
No,
think
I am saying that. See, suppose I have two genders, male and female. Now I want to know how many males own the phone, which is 25%, and how many females own the phone and not own the phone. Sorry, is 22. So and similarly, if you say how many females own the phone is 77, and how many males who own the phone, it's 75. So it doesn't depend on the gender, is that gender is male or not, but your proportion is same.
yeah. Now I got it. Like it's like saying that if I'm able to differentiate female and males, but
Yeah.
here the proportional division is same. That's why the relation means I cannot predict.
Yeah, I can't say that that uh, if the person is male, then he female, and otherwise he doesn't, female doesn't have smartphone. Or I can't say that if person is female, then female have less number of mobile, means less female, more male have mobile phone, but less female have mobile phone. I can't say that. It did
We got it now. Thanks.
Yeah, it doesn't depend on the gender. Okay, like this, if you see here, I have relation between what, given that smartphone have or not have, I have gender proportion, that uh, the condition is that person doesn't have mobile, then what is the proportion, that she is male, or she is female and he is male, and similarly he have mobile phone, and what is the proportion, that she is male and she is female and he is male. Okay, so if you see the data, uh, the person doesn't have smartphone, and the proportion of C's female is 41, and C's have mobile phone, and C's female is 44. And similarly, if you see person doesn't own mobile phone and he is male, and he is does not own mobile, he own the mobile phone and he is male, both are same. So I can't say that owning mobile phone is depend on the gender. Okay.
Okay, sir.
Yeah.
So, for the second case, we can say na that there is a relationship because the
In
distribution.
this income one.
Yeah, the lower one.
Yeah, we can say.
Mhm.
Yeah, if see, if you plot the chart, see, here is the chart. Now, if I create the 100% stack bar chart, if you see, those are the, I think I am right. Those are the female who have mobile phone. I think, yeah. Let me check. Yes, no, these are the, yeah, this one is the portion which tells about that female have smartphone. Okay, and this is the portion which tells the male have smartphone. So if you say the proportion is same, okay, so it doesn't depend, owning a smartphone, it doesn't depend on the gender. Okay, you got the point? Or
Yes, sir.
okay, in this case, in income case, we have this type of the 100% stack chart, where I have the people who doesn't have, yeah, this one is the income level. Yeah, so in, if your income is high, then this is the portion which tells about you own the phone. That is, yeah, and this is the portion. Let me see. Let's see. Income or say smartphone ownership. Okay, so is the high income, and this one is same, right? High income only 10%. Yeah, so this portion tells about just a minute.
It should be low income group. 3 is the low income group, and 1 is the high income group.
Yeah, but is this column? Is this row frequency or column?
Sir, it's a row frequency because it's dividing by the row total.
Okay, so total number of person who have high income is 20. Then those who have, okay, no smartphone is 10%. So why
So
this
that
number is...
the high income group is number 1. It's depicted on the row as
Okay, sorry. Yeah, this one is high frequency, no? Yeah, so if you see, this portion is very high, which tells about the income is very high. So smartphone user is owning a smartphone. If your income is high, then you can, the probability that you own the phone, yeah, proportion that you own the smartphone is very high compared to this one. So you can easily see the relation that income level change the other variable, which is smartphone ownership. Okay.
So, well, like,
One,
is
yeah.
it same as saying that if I am high income, a person belongs to a high income group, then
Okay.
it's more likely that he owes a smartphone.
Yeah, same. The proportion that you owe, the high income guy own the smartphone is very high. You can see. Yeah, this portion. This one for yes. Okay.
Yes, sir.
Yeah. Okay, now we have, okay, now this is the way how to summarize the two categorical or relate the two categorical variable. Okay, now next we have relate to numerical variable. Let's just see. This one is 44. So for that we have scatter plot. So I think everyone know what is the scatter plot.
Yes, sir.
Yeah. So what we have in scatter plot? So can anyone tell? Basic.
So,
What is the first point for scatter plot?
so there is a response variable and another is
Yeah.
Explanatory variable.
explanatory variable. Yeah.
Okay.
Thank you.
So where is the explanatory variable and where is the response?
Explanatory variable is on the x-axis and response variable is on
On
y-axis.
y-axis.
Okay. Okay. Or yeah. So that's the so you see we have age and we have, so first like you use this type of tuple 75. Okay, so which tells about this is the first variable and this is the setting variable, and you plot in this chart 1 and 70 like this. Okay, this is
Yes.
the scatter plot. So now how to summarize data with the help of scatter plot? So for that we have data of householder, house and size of house and price of house. Okay, so there is a scatter plot of that data, and we have two data. One is this is data 1 and this is data 2. So see here, if your house size is small, then price of house is also small, and like this if you go the higher size, the price of house is also increases in data 1. Okay, but in second data, if you see you have a small house which whose price is very high, and there is another small house whose price is very low. Similarly, if there is one house whose price is very low, medium house, and there is another medium house whose price is very high. Similarly, if you see in higher portion, the big house whose price is very low, and there is another house whose price is very high, not very high in the pattern, that is a bigger house has higher price. So this data, in this data I can say the size of house depends, price of house depends on the size of house, but here I can't say that size of house depends on price of house depends on the size of house. Okay, so now there are some, in next lecture we have some measures who describe these things. Okay, just a second. Yeah. So firstly we will see now, in previous one we see some pattern
So,
like
a small query, please. For the graph that you just showed
yeah,
of data 1 and data 2,
yeah,
if what I see it as, like in the data 2, I can only effectively draw a horizontal line. That's the reason
yeah,
why no relationship.
no, it's just 1 minute. In previous one, yeah, yeah, yeah. If you draw the horizontal line, see, yeah, you want to say I can draw a horizontal line.
Yeah, because I'm able to draw effectively a horizontal line. That's why I can say that X, I cannot uniquely determine Y using the size. Because for
What?
multiple sizes, means if I draw an effective line
Yeah.
here for this point equivalent, so that's essentially saying that I cannot determine price based on a particular size. So
No, no,
that's
no.
okay.
See, if there is one another data where the points are like this, okay,
Yeah.
and you can say like some around this, okay, then what is the best line which fit this data? This.
Yes, sir.
And in this case, what I can say that no matter what is the size, house cost is same. Okay.
Yes,
But
sir.
here I can, but if I draw this line tells me that no matter what's the size of the house, price is always same. But this is the not true. There are price which are fluctuate. There are house of small size have less price, have large price. You can see this difference.
Okay,
So you
sir.
can't say that that line if I draw the horizontal line and this thing.
Sir, for this diagram that you have drawn upside, the blue
Yeah,
one,
this one.
yeah,
Yeah.
is it predicting a particular Y, or is it we cannot consider this particular case?
Yeah,
Means,
it's predicting the about the data, na. See,
yeah.
in this graph, by this graph you can say what no matter what's the size of a house, price is always same. Okay,
What's
maybe
that?
this is not true in general, but by this data you can say.
So, but that essentially it's not saying that whatever the X is, Y is not dependent, Y is always constant.
Yeah, y is always constant, so you can say so this is the dependency, na.
It's means Y is in respect of X value, I am having only a single Y value.
Yeah.
So in that case, can I say that it's predicting Y?
Yeah, I can predict. See, if I say any statement about the data, then this means I am predicting. Here I can't say about the data. Here I can say that no matter what's the size of house, price is always constant. This is my prediction.
Okay, sir.
Yeah, this and this is the part of usually in regression and this analysis, but yeah.
So because of that, I have a slight exposure. That's why I was diving into it, right? Because I was relating it, and it seems to me that
Yeah.
whatever the X is, Y is not changing. So whether I take a X value in some data or not, Y will still going to remain same. So it's not a dependency thing.
No.
That was
By
my thought.
data we are predicting about the. See, I have some observation, large number of observation. I pick some data, some sample. Okay, in regression we did this type of data analysis. We some small sample which is fair sample, means random sample. Okay, not biased. So I can plot these data in this scatter plot, and then use use
Sir,
the concept of, yeah.
Sir, I think we can dive into it after the class ends because a lot of students will not get what we are
Okay.
like.
Okay. Okay, let's see. Just let me change the slide. Oh, sorry. Yes. Okay. Now we have. Okay. So now we have 4 points. What is so we see some pattern in the data, like data is like this, data like is like this, or data is like this. So firstly we have to mention four things. What is the direction, what is the curvature, and how much is the variation in the data, like this. If in second example you see that the very points are very separate from each other, and if I have one data where the points are very close to each other, so this tells about variation. And there is another thing which is outlier, those points which are not behaving uh, uh, like this pattern. Okay, let's see what the all these things. So we have direction. So here yeah, can we say about direction of this data?
It's in increasing trend.
Yeah, it's increasing trend. Okay, after as the house size of house increases, uh, prices also increases. Okay, in this data, what we can say about the direction? Direction is telling about
It is
how the one variable affect the another variable. Like in this example, the direction tells me about as the size increases, house size increases, price is also increases. In this example, what the data says? Can someone tell?
so
It's in
as the price increases, the age of the car decreases, I think.
As the
No,
age
no,
increases,
was
the price
one second.
decreases.
This
Yes,
one is the
yeah.
yeah. Say
Okay, sir.
yeah.
So as the age of car increases, the price also decreases,
Yeah.
like this.
Yeah. Okay. So this is the down trade. Okay. Okay. Sorry. Now we have curvature. Second point about curvature. So here, what is the curvature? It's not like straight line, but yeah, we can say it's up trade uh, and linear. Here I can also say it's down trade and linear. But here points are there is some curvature, not linear like this. This is some curvature is there, and similarly here. So mostly we learn about linear type of pattern. Okay, yeah. So this is the curvature. Yeah. Now we have variation. So what's the variation? Can anyone know?
I think the variation of any points like any points which is lie on the range, or it means there is an outlier which is not lie in the data set, which is a totally different point from the data set.
Yeah.
I think that's
So
a
you
variation.
can So you can create some bound in this data so that all of your observation are in this region. Okay, this is one. This is what then I can say that my points are very
It is
tightly
clustered.
clustered. But if my
Yes.
points are like this, then I can't say the bound is very high. Okay, here my bound is very
Okay.
low. This one is the bound. Here bound is very high. So huge variation is there. So there are two. This one is tightly clustered, and there is very. Now we have outlier. So see, if you see this data, this one is the size of house. This is one is price of house. So as the price size increases, price is also increases by some pattern. There is a linear pattern, and most of point are around this data. But there are some points like this, that my house size is very big, but price is very low. It's even lower than my smallest house. So these type of points observation in my data are called outlier. Okay. So these are the term which are associated with what? Scatter plot. But firstly, direction, which tells about how the one variable talk about other. Then we have curvature. Is this my trade is linear or not? Then we have variation. Then how much variation in my data? And after that we have observe outlier. Those are not usually follow the trend. Okay. Any
Yeah,
doubt?
if for a data we have like some data that have sometimes increases but sometimes decreases
Yeah.
means so this association of increase and decrease in directions is considered like as a curvature or something different.
You see, if you want to say if your data points are like this.
Yes, sir.
Okay. So if you see in this part, your curve is decreasing, and in this part, it is increasing.
Yes, sir.
So you can't say that it is. See, as the price increases, this values usual, as you can see, this is increased, but not fully increased. Here, this is decreasing. Here, it is increasing. So you can't say that your data is trade up or trade down. It's between
Yeah, it is like local maximum, local minimum, is
yeah,
it?
yeah.
So
Then,
it's
yeah,
in the curvature segment, not in the direction thing.
but
Means I cannot strictly say that it's strictly increasing.
yeah,
So it's like saying that it's some sort of curvature.
yeah. Okay.
Yes, sir. I think it depends.
But
It depends the reference about which we are talking.
yeah, see, if data point are like this, then you can say, and after that this one is like this. Assume that this part is your income range, and this one is low, and this
Low
one is
income, high income.
okay. Just a second. If this is high, then what is my exponential variable? Yeah. Okay. This one is. Let's see. No. Example.
So we can take some arbitrary like labels for x and y axis.
Yeah.
So
So if in this example, if you say see that this is my initial trade, and after that my data is going like this. Maybe something happened, and it's like, so you can't say that is the trade up and trade down. Okay.
okay,
Trade
but
up, yeah.
But it's curvature. It's curve.
Yeah, it's curvature. If it is linear, then if you see the linear function, then it's either fully increasing or fully decreasing. You have some slope, and then it goes like this, or if you have another slope, it goes like this. If it goes like this. So if your data is not linear, then you can't say that it's fully or increasing or fully decreasing in
So
some
we talk
case.
about directions when we have some sort of linearity.
Yeah, mostly in linear case.
Okay.
In exponential case, you can also say.
Yeah. Yes, sir. Got it. Thanks.
Yeah. Okay. Now we have next file. Now this is the graphical measure about relating to numerical data. But what is the mathematical tools? Okay, so we have two things: covariance and correlation coefficient. Okay, after that we have some R square, which measure the goodness of fitness, and that thing, how much your goodness of fitness measure the. Okay, we will discuss it. So what is the covariance? So it tells about strength of the linear association. We only measure linear association. We can't. We are not talk about the non-linear about things. Okay, that will be. I think it will the last part of your data science course. I don't know, but yeah, non-linear regression and that. Yeah. So this is our data, age and height. See what correlation tells. First, this one is your data point like this. So for this point, there is one x value, there is one y value. Similarly, for this value, there is one x value, there is one y value. So if you take all the y values and find the mean of these values, let's say this one is the mean, this one is y bar. So draw the line, and similarly you have x values. Let's say this one is mean of x values observation. So now, so if I write this one is y bar line, this one is x bar line. So those points who lies in this okay, some points are also here, some points are also here. Okay, so for this value, x value is less than x bar. They are lying in left side of this line. So for that, x is here. So what is the value of xi minus x bar?
Negative.
Yeah, negative. Similarly, for this value, y value is lying here, and y bar is above than y. This one is yi. So what is the value of yi minus y bar? It's also negative. So
Yes.
yeah, for all those points who lies in this region, for that x bar minus xi minus x bar is negative, and yi minus y bar is negative. For these points, those are lying in this. So for that, y value is greater than y bar. So yi minus y bar is positive, and but xi is lying left side of x bar. So xi minus x bar is negative. Okay, for these value, both values are positive. Xi minus x bar greater than 0, and yi minus y bar greater than 0. Similarly, for these values, xi's are right side of x bar. So xi minus x bar is greater than 0, but yi are less than this y bar. So yi minus y bar are negative. So what is the product for these values? Product is negative. Positive into negative is negative. For this, product is positive. For this,
Positive.
product is positive. For this, negative.
Positive.
Yeah. For this, these data negative.
Negative.
Okay. Now, I need some space. Okay. So see, if then this one is my y bar line, this one is x bar y. If more number of data are here and some lesser number of and not in wild range, some points are here. Okay, then if I find this xi minus x bar, yi minus y bar, this will be what?
Negative, sir.
Yeah, you can say, but it will be maybe negative, maybe positive, but I took most of the points are here, and these points are not in wild range, they are only in this range. So I assume that this is negative. Okay, so what is the trade?
Okay, sir.
So what is the trade? Most of data is in this range. So this one is my covariance. What is the definition of covariance? X bar minus yi minus y bar divided by
And
n or n minus 1.
if I'm talking about the sample covariance,
Yeah, I am talking about sample n minus 1. Okay.
so n
If-
minus 1.
Yeah. So this quantity, positive or negative, doesn't depend on this. Okay. It only depend on this. Okay. So if this quantity is negative, this means what? Most of the points are here, or you can say in wild range, means most of the data point, and in very far from the x bar and y bar, then this trade is negative. But if this trade is positive, which means what? Most of the data point are here. Some are here, but more are the in this. Then I can say my trade is what? Positive. And I'm only talking about what? Linear trade. Because covariance only talk about what? Linear association. Okay.
Yes, sir.
Linear association. Strength of the linear association. Okay. So what is the strength of linear? What do you mean by the strength of linear association? Means if I say that covariance is positive, then most of the values are in this type, not like
Is
this.
how much they clustered.
Yeah, how much they clustered. Yeah, not like this. Okay. Understand?
Yes, sir.
Yes.
Okay. Okay. Now this is the part. See, then we have some observation. As the see, if xi's are increasing, okay, then mean will be somewhat in between. In increasing data, mean is always in between, or maybe here and maybe here. Okay. And if I find this xi minus x bar, then these terms are negative and these are positive. And if this is happening same in this data, means if xi is increasing and yi are also increasing, both are in increasing order, then what? This one is negative, this one is negative, this one may be negative, and this one may be positive, but after that they are mostly are positive. Then the product is what? Positive, positive, negative, positive, positive, positive. So most our data point are, most our terms are positive. So what covariance is also positive. Okay. So it tells about what? As the one variable increasing, if another is also increasing, then my covariance is positive. Got this point?
Yes, sir, I got it.
Or any other participant?
Got it, sir.
Yes, sir.
Yeah. This is the
Yes, sir.
important part. Okay. Like this here, the age is increased, but price is decreased. So what is the trade? It look like this. Okay. So there is one point which is what? See, when large values of x tend to be associated with the large values of y, means as the 1, 2, 3, 4, and this one is also this large value associated with this large value, this large value associated with this large value. If trade is this like this, then sign are same. Sign of this and this is same. Okay. And if they are different,
Yes, sir.
then sign is different. Okay. By this you can say that trade is upward or no downward. So this is the formula of population covariance and sample covariance. You already know, I think, these formulas. Now
Hello.
we can jump.
Hello, sir.
Yeah.
Could you explain previous one?
Which one? This one?
Yeah. No.
Okay.
Yeah, this one.
Sir, can you explain a unit of covariance?
Yeah, I explain. Okay, unit of firstly we explain this. I explain this after this. Okay, what is the problem?
No, before after that you explain. Not, I didn't get it. Yeah.
This
Key
one or this one?
observation.
Key observation.
Yeah,
See.
this one. Yeah. So,
okay.
yes.
So what's the point? If the large value, see, this is your X data and this is your Y data. Okay, if the large value of X is associated with large value of Y, or small value of X is associated with small value of Y, like this, second small value associated with of X
Yes.
associated with second associate value of Y.
Y.
Then what's the sign of Xi minus X bar? And Yi minus Y bar is same. We saw this in here. See, small value, no, not this. This one. See, small value of X is associated with small value of Y.
Y. Yeah.
And large value of X associated with large value of Y. So sign of, so this means this data is increasing. So mean is somewhat here. Similarly, mean is somewhat here. So Xi minus X bar in this case for these values is negative, for these positive.
Okay.
And similarly for these values Yi minus Y bar is negative and Yi minus Y bar is positive for this value. So you can see the sign is same. This means what? If you multiply this, then most of the, see, in covariance term we have product of these values. Okay, so this is positive, this is positive, this is 0, this is positive, this is positive. So sum of positive terms is what? Positive. And 1 by n minus 1 doesn't any effect on the sign. Okay, it is always positive. So what we mean by this? This means
This
as the
is
X
fun.
increases, Y is also increases.
Increase.
So which we can see here, as X increases, Y is also increasing. But in the reverse case, as X increases and Y is decreasing, then we have what? Like this type of trade, decreasing trade. Okay.
Yeah, got
You
it.
got it or?
Got it.
Oh, okay.
Actually, that time you didn't mention that X I minus X.
Okay.
B.
Yeah, I already
Excuse me, sir.
mentioned this. So, yeah.
Sir,
Yeah.
if there is a data given, the number of hours increases, by which the number of calls increases, then after that it decreases. So, sir,
Okay.
can we define the nature of covariance for this type of data, sir?
What the question? Number
So
of
question
hours?
is increases. Suppose there
No.
is a 9 to 5, there is a job person
Okay.
who
Okay.
the number of hours increases for 9 to 12. After that the number of calls decreases.
In this time period it increases.
Then after that, from 1
Okay. And between
from 1
12 and
there is a break.
okay.
It decreases, means there from 12 to 1 there is a lunch break.
Okay.
So there's a so can we define, sir, the nature of covariance for this type of scenario?
Yeah, we can define, but it can't tell about that.
So, but if essentially we see for the complete X, so it's not a linear thing.
It's not.
Yeah, it's not linear. So we can find
Yes,
covariance, but we can't say about the its trade is upward or downward, because it's a not linear data, na. You have some point are here and then here. I
So, sir,
can't. I think I can't. Yeah.
can we say the nature of covariance is positive or negative like this? So it is. Can we say?
Okay. In this case, let's assume that this one is yeah. I need some clean page. Okay. One. Okay. Just yeah. Assume that I have one data. This one is 9 to 12 and 1 to 3. Okay. Data is like this.
Okay, sir.
This, after that, your data is decreasing. Okay. So firstly, find the mean of this 9 to this. Mean of X variable. Don't count in hour. Let's say this is your 1, this is your 2, this is your 3, this is your 4 for simplicity. This is your 5 and this is 6. Assume that this is the mean of X variable and this one is mean of Y variable. Okay. So see.
Yes, sir.
Some points are here. For that, product is what?
Negative.
Oh no. For that,
Negative.
no. Product is positive, no. Both terms are negative.
Yes,
so
sir.
product is what?
Positive, sir.
Yeah. So for this term we have negative. For this we have positive.
Positive.
For this negative.
Negative.
Okay. Yeah. So we see if the data which is okay, these are the very less point. This is the misleading data. Okay, very less point are there because these are the number of calls, na. Oh sorry.
Yes, a number of
this
calls.
graph is very misleading. Sorry. Graph is like this. As the time increases, 1, 2, 3, 4, 5, 6. Number of calls like 1, 2, 3, 4, 5, 6. Okay. Now see, in morning, in this period, you have most of the call. Okay. After that, in this period, you have some little call. After 3, this one is the break period. Then we have very less number of calls. Okay. Now mean of X is this part and mean of Y is all these data add and how many calls are there. After that, assume that this one. Now it depends on the how much call is are coming in this period, in this area, in this area, in this area. You can't say that by simply by increasing or decreasing. But
Okay,
because
sir, I got it.
if this in this period 2 to 3 period, if more number of calls are coming, then this one is negative and this one is positive. So maybe this sum is negative, or maybe in this period more calls are come, then this one is positive, more number of positive term are there, less are negative. So maybe it's positive, maybe it's negative. Yeah.
Yes, sir. So the thing which you try to say, I understand. But sir, I was thinking, so can we able to define the covariance for whole scenario, sir? We can't define the covariance of whole scenario like this type of thing.
You
It
can
is
find
true.
covariance, but it can't say about your data.
No,
It
sir,
says
the
that
nature,
your data is
nature
not
of the
linear and your covariance is lie between that range, 0.3 or minus 0.3 to plus 0.3, like in this range. You can't predict that data is linear or not. That means its data is not linear.
So,
Okay.
I think that this point can also be noted as we are calculating this covariance now. In
Okay.
that product term before summation thing, if most of the terms are positive or most of the terms are negative,
Yeah.
then we are definite that it is like linearity is there, whether it's increasing or decreasing. But if we see that like around half are positive and half are negative, then
It's
we are
also
sure that
depend on the that how much point. See, if x is very far from this x bar and y is also far from this y bar, then this positive term is very high, and assume that these points are very near to this point. So it doesn't depend that you have very large number of point are here, and in that case maybe your data your covariance is positive. Yeah, it
that's
also depend on that.
uh,
Okay.
yeah.
Yeah. So just remember that your covariance only measure the what is. See, I think in this slide we have that point. Okay, firstly we see the unit of covariance. After that we see that point. Okay. So what is the unit of covariance? So see, if x is in covariance formula, you have what? Xi minus x bar and yi minus y bar. This one. So this unit is assume that this is time hour, and this one is what? Kilogram.
Kilometer,
Okay.
sir.
As maybe okay. Kilometer. Okay. So what is the unit of covariance into this? Okay.
Kilometer per hour.
Kilometer, no. Kilometer into hour, not per hour. Yeah.
Why?
Okay. So this is the unit of covariance. Someone have doubt in?
No, sir,
Yes,
it is
sir,
clear.
clear.
Okay. Now we have next slide. Just a second. Now I think in this part we have that how much data. Yeah. Now we know what is the covariance we know. Now we understand what is the correlation coefficient. Okay. And which tells about what? Strength of association between the numerical values. Now let's see what is the correlation. So correlation is yeah. See, this is your what? This is what?
Covariance.
The numerator
Your
of covariance.
yeah. So I can, if I write this like, okay. Yeah. See, if I write like this, 1 by n minus 1, here I have also under root, in inside under root, I have n minus 1, here also. I justly multiply and divide by this. Okay. Here and here. Okay. Any doubt in this
No, sir.
transformation?
No, sir.
No, sir.
Okay. So what is this?
So covariance.
Okay. And what is this?
The standard deviation of x and the standard deviation of y.
Okay. So this is the formula of covariance, correlation coefficient. Okay. It's interpreted as R. Okay. Some in some book it's interpreted as rho and rho xy. Yeah. Here it interpreted as R. Okay. Okay. Now what is the unit of the correlation coefficient?
I think it's an unitless quantity because units are cancelled.
Why?
So because units are cancelled
Yeah.
in the covariance unit and values.
Yeah. Okay. Everyone got this point, or I
Yes,
have
sir.
to explain? Yeah. Okay. Now there is two remark. one is unitless, no unit. Okay. And another is one. The covariance is line between -1 to 1. Okay. These are two remarks. I think it's part of probability theory and that thing. So we can't cover here. Okay. Just remember that covariance is always lies between -1 to 1.
Okay, sir.
Yeah. So these are the data. Now we have main point is here. Yeah, this. Okay. Now what is the firstly we have I think another thing is also this one is okay. So see this data is this correlation coefficient divided into 4 parts, 1 and minus. So if your correlation coefficient is 1, what is the mean by that? Can anyone know?
So, highly associated thing.
Yeah. If it is 1, then you have a straight line. Okay. If it is lies between 0.75 to this, then what you said highly what?
So
What is the term?
strongly positive linear association.
Yeah, strongly highly linearly associated. And similarly in this side, if your correlation coefficient is what? -1, what is the mean by this?
A strong negative linear association.
Yeah, like if it is -1, then you have exact negative association, exact line. You have exact line. Your all data points are like this. And if it light is between in this, then your data point, some data point can be, it is like this, and here it is like this. Okay. After that we have is 0.75. After that we have 0.50. We have 0.5. In this term, what we call is this reason?
Positive linear.
Sir, positive linear association.
Positive linear. After this we have 2.5, no sorry, 0.25 and 0.25 plus and minus. What is this reason?
Weak.
Scattered.
Weak. After that we have this part. What is the mean?
There is no association.
Yeah,
No
scattered
linear
data.
In this
association.
range.
Yeah.
No linear association.
Yeah. If your correlation is 0, what does that mean?
Data.
That your both you can't there is no association between x and y. Okay. No association.
Okay, sir.
Yeah, non-linear. You can say not your data are not linear.
Means if it's 0.
Yeah.
Means it's okay. It's like if it's near 0 still, then that's also like weak
Yeah,
linear.
that is also weakly linear. But if it 0, that your data is non-linear. I think there is one term. I don't know exact term, but yeah.
So for the case in that a few minutes back, that one of the candidates asked that in a range it's increasing and after that it's decreasing.
Yeah.
So we can see that thing by using correlation. If it's like 0 or
Yeah.
around 0, then it's weak linear relation.
Maybe that is not 0, but yeah, it's weak.
It's weakly linear.
Yeah.
Okay, thanks.
Okay. But I am not sure about that. Yeah, I see. Yeah, we will discuss in next class if possible. Okay.
Okay, sir.
Now we have another thing is what? Goodness of fitness. So if I have data like this point, So there I can pass line. There may be more than one lines, but this is the line for that. Actually, is the advanced topic. Okay, this is the line which is fit, which describe most of. Okay, just see. This line. If you see this line, so some point are above than this, and some point are below than this. Okay. So if you say that this line describe about the these two variable, okay, how the one variable changes other. If you say this, then there is some error term are also there. These are the error term which can't predict correctly. See, this line says that your for this value, just a second. For this value, your y value is this, but it's actually this. It can't predict correctly, but it predict most of the data point. So if these error, some of these difference is very less, then I can say that this is the most appropriate line which describe this data. Okay, that is the goodness of it. There is one line which describe about your data. You can predict how one variable associate with the other. Okay, got the point? Or
Usually use the sum squared
Sir.
for this thing.
Okay,
yeah,
sir.
square,
Sir,
yeah.
like squared
Sum of
sum
square.
error.
Square of sum. What?
Squared sum error.
Yeah.
Sir, it is this
Can you,
quantity
sir,
is a
repeat
squared
it
sum
again,
error.
sir, once time?
See, I am saying that this line is telling about that how one variable is associated with the another. That if my value is 2, this means the size of house is 2, then value is 100. Yeah, around 100. Okay, then I
Yes,
am
sir.
saying that this is the goodness of it, and this is the best line or the appropriate line which describes. So in this case, see, it can't predict correctly. There is some error term. See, in this point, the actual value is this, but line told me that this is the actual value. So there is some error term. You got this point?
Yes, sir.
Yeah,
Yes, sir.
got
It is. I got it.
So this line is that line which
Yes, sir.
minimize this error, this sum. There are, I can say this one is that line, but this is not predicting my data. Most of, see, just see. If I say this one is my goodness of fitness line, then most of point are below than this. This is my error. This means my error is very high about prediction. I can't predict exactly because I am predicting about the population from the data. So there is some error, but I want to minimize the error. So this is the line which minimize this error. Okay, this sum. This is the advanced topic, but yeah, you should know this thing.
And what is that line is called? Like,
this is the
line
of
with
fitness.
minimum error.
I think is the regression line or something. There are some SL.
Best fit line, I think. So.
Yeah, there is best fit line, or there are something. Another term is
Yeah, SSC math we had now.
Yeah, best fit. You can say best fit line.
Yeah.
Yeah.
So why we are learning this?
So see, you have data, some population you have. You took some sample. Yeah, and then you plot this data. Okay, then you want to know about how one variable is associated with the another. See, this is your income and this is your expenditure. Assume that. Okay, Now you want to know that how the income
changing with
how the
respect to
expenditure
size.
what
Size is changing
Dependency
with
of
respect
each
to
other.
price.
size of what
Size of like size in a square foot is changing with respect to price of that area.
yeah how the income how the expenditure behave on income is high income means high expenditure or this lifestyle about okay so
Yes,
I
sir.
took some data yeah okay
Yes,
I
sir, I
took
got it.
yeah I took some data I plot this and then I found the best fit line which predict about my data then by this line I can predict about my population okay
Okay.
this is the use of this okay
So what's
so
this R square term here?
yeah this is R square term tell about how this line predict about my population or my data see here R square is 0.647 this means 64% this line is accurate this line predict about the sample
Okay.
means this is very high so
Now,
decent line.
okay.
Yeah if my
How
R square
did
is
we
very
found it?
what how
How
R
we
square
found?
is square of this
Yeah.
yeah.
How we got this number of R square?
R square it's regression analysis term is coming from this like you
Error.
have
There should be a question. No? We didn't
no
have
no
to.
no I think there is no question about this
Okay.
yeah because
He's
this
asking how is the R calculated?
okay so R or this R square
Both.
see,
Both are same, not same.
R is your correlation coefficient
Okay.
okay and R square is your R square
Yes, sir.
okay and if you want other thing is very high I think your doubt is this
So here R square is the square of correlation.
yeah
Yes.
Is it? Yeah. Okay.
okay
So but that means that the value of both the R capital R and small r should be same now.
what
Like if R capital R square is equal to small r square.
no this is the one notation this is not R square that this is the name assume that this is R assume that
Okay.
R is your R square okay this is the notation okay
Okay, sir.
yeah
Uh,
now we have one line equation of this line see if you have one is your variable two variable are there one is price and another is range so by this equation you can describe about sample or population this is the equation of this line okay this is not very that thing. Okay okay this one I already talked what is R square and relation yeah now what we have there is one more slide I think
Point by C relation correlation.
what
I think it's a point by C relation correlation it is left. Only that
okay
topic.
yeah yeah this one is what summarize the sheet yeah this one is done okay now we have next okay now we have we firstly summarize about what two we have firstly we have two categorical data then we have two numerical now we have one categorical and one numerical okay now how we summarize these two variables how they are related so for that we have what If we plot scatter plot, then this is one. So assume that this is the male, this is the female. Okay, and these are the marks. Then scatter plot look like this. For one, like see, if you plot the scatter, how to plot the scatter plot? We have some x and then we have y, but here x value are either 0 or 1. Okay, so all the
Yeah,
values
that is
are in one side, other are in other side. Okay, so it's like 0 and y. This one is 0 and y, and this one is what?
1 and y.
1 and y. Okay, so these are, and how to describe from this? See, these are the okay, these are the female, these are male. So these are marks of male student and these are female. So if you see that both of these data are look similar, this point. Okay, so this means marks doesn't depend on the gender. Okay,
right.
yeah. So here, if here you see female marks is less than male. So here marks depending on the gender. Okay.
Yes, sir.
Yeah.
So,
Now we
but
have
if we have a slight overlap there,
overlap means
in
like
slight
this.
overlap, yeah, slight, yeah, like this.
Then also most of males have marks higher than female, no?
Yes, sir.
Yeah. So this means males perform well in exam than female.
Okay, for most of the cases, yeah.
Yeah. So it's also depend on the what is the proportion. If proportion is same, then we assume that in your class, assume that only 10 girls and there are 20 boys. Okay, and all 10 marks girls marks is this, and 20 boys out of 20, assume that some are in this range and some are in equivalent to girls. In this case we can't say that males performing well. Okay,
To take
or
the sample size
either
like 10:10,
what if we take the sample of 10 and 10,
then we
it
can say.
then we can say, yeah. Then we can say. It also that's why I'm saying that it also depend on the proportion of male and female in the class. Okay,
Yes, sir.
Okay, sir.
now we have this biseries correlation coefficient, and this is the method of finding by till now.
Yes, sir, Gautam.
Yeah, till now you have any doubts and anything?
No, sir, I have no doubt.
Okay, and in any practice question or assignment and any?
Sir, I have doubts, sir, from PYQ, sir.
PYQ.
Yes, sir. So I've solved, sir, but I not get the sir correct answer.
Just a second. Where? Week 4.
So, no, sir, I have doubt from previous year question, sir.
Okay, okay. I have okay. We will discuss in question solving that day. If you have doubt from this, then you can ask. Yeah,
No, sir.
what's
Sir,
the question?
when the sir question wait, sir, question is just wait.
Any other question?
Yes, sir. Question is says the mean and population standard deviation of marks out of 500 scored by a student of class 10 in an aptitude test are 30 and 5 respectively.
Okay.
If the marks are modified, so here it given in formula, modified marks equals to 2 times of marks plus 5 divided by 5. Based on the given information, answer the sub questions.
Yeah.
So the first question is, what is the mean of the modified marks? And the second
Okay.
question is, what is the population standard deviation of the modified marks? So
Okay.
I have done the I have calculated the modified marks,
Yeah.
but I am not able to get the population standard deviation. Every time I got 16, but the correct answer is 2, and the modified marks is 13.
Okay. You know how the relation, what is the relation between that modification of mean and variance?
Yes, sir. Yes, sir.
If my mean is a if my data point are like xi, then mean is mu. Assume that mean is mu. Okay. Okay. You
Okay, sir.
can able to see this screen now?
Yes, sir. Yes, sir.
Yeah. Okay. Then if data points are xi, then what is the mean?
Summation of
No,
xi.
in terms of mu, a mu. Yeah. You know this?
No, sir.
Okay, then revise notes. Then there is this one is already discussed. Like this, if variance is if this one is the variance of your xi, okay.
Okay, sir.
Then variance of axi is what? Can anyone tell?
A square.
Yeah, a square
A
sigma
square.
square.
E.
Okay. So these are the relations. Just see these relation and then I think it's the easy problem.
Sir, 4.3.
Okay.
Sir, I have sent the question, sir, in the chat, sir.
Okay, I understand your question, but you don't know relation, na? That's why I'm saying.
Okay, sir.
Yeah, by this you can easily solve your question. Yeah, what's the next question?
4.3 first question.
4.3. Where is practice assignment 4.1? 4.
Not practice assignment, sir. Just
Okay.
activity.
Activity question. Oh, sorry. Yeah. Which question? Which question? Oh, there is only one question. Yeah, in this question, which part?
What is the relative frequency of bought items corresponding to website A? Means 1000 by 6000, right?
1000. No. See. What is the relative frequency of bought item? Bought item are these. Okay.
Yes, sir. 1000 by
With
6000.
corresponding to what? Corresponding to what? A. So
website A.
see in this column.
Yes, sir. I have seen 1000 by 6000, na, sir.
No.
That is
Why 6000? 3000. 3000, na? Corresponding to
Oh,
website
Total
A.
is 3.
Okay.
Yeah.
Sir, what I did is 1000 plus 2000 also I did. Okay, sir.
Yeah,
Thank you.
no problem. Any other question?
Sir, actually, I missed yesterday graded assignment session. So can we solve third one of week 3?
Week 3.
Just give a hint.
I think I already solved in beginning of
I
this
missed
session.
that. So
oh, okay. Yeah, this one is I already discussed in last solve with a session.
right. So, but I missed. So there is not any recording.
Okay,
of
I have
that
slides.
session.
I am showing you.
Could you share it?
Yeah, just a second. I already shared in at that day also. Just wait. It's in recycle bin. Okay. Restore.
And about today's last concept you were saying about the correlation between association between numerical and categorical variable.
Yeah.
So there can we find this covariance or correlations?
Yeah, there is one by serial covariance is there, correlation is there, no?
Can we find direction? We can't. Huh?
No, we can't. See, in this slide, in last time, there is one question. See, yeah, this one question. This question, see, you have data where the 5 data set is there, and mean and standard deviation is given. Okay. Then that guy noted that one observation is wrongly noted there as 6, but original value is 1. Okay. Then question is, what is the original mean of original data set? So firstly, I found, so what I know this one, x1 plus x2 plus x3 plus x4
Yeah.
plus x5. I know this one divided by 5. Okay, now assume that this data point is wrongly collected. This means its value is 6. Now I want to remove this value. So for that, I remove 6. And now I want to add this value as 1. Okay. For that, what I did? Plus 1.
Plus 1.
Now what the value?
Divided
Now
by,
I know this value. This value is what?
This is 5
10.
by
10.
10.
Yeah. Minus 6 by 5 plus 1 by 5. What's the value? 9. That's the answer. And for variance, you have to be use this formula, which I already explained in that day.
Oh, okay.
Okay.
Okay, sir.
Just find this summation xi square, remove first term by 36 minus 36 and add plus 1. You can easily solve this. Okay. So you want to so I have you want that share in chat?
Yes.
Yeah, you can.
I already shared that day.
Sir, can you put it in the calendar?
Calendar?
Yes,
Yeah,
sir.
Which calendar?
The Google, if you put it in the calendar, then Google Calendar,
We all
everybody.
can access it, right?
I don't know how to.
So it's there in portal also.
Okay. Now I already said this.
Okay.
No problem. Yeah. Okay. Any other doubt? In week 4?
Not completed.
Okay. So that's it for today, Tyson. Or you have doubts?
Just one doubt. Like usually we don't have a plots available. What we have is a data table
Yeah.
of some observation and so. So if we try to find this correlation and covariance, how we can test using them that it's linear or there is there exists a relationship between two variables that's linear or not.
So that's the meaning of the correlation coefficient, no? That if
but you said that you will be confirming in the next session, so I was
I also in non-linear case, I know that correlation coefficient can't say about that.
so, but we usually don't have a pictorial graph now.
Yeah, we have no
What?
pictorial graph, but if the correlation coefficient is lies between 0.75 to 1, then you know your points are trade up and clustered, tightly clustered. Okay.
Yeah.
You know, but if the value between 0 to 0.25 minus 0.25 to 0.25, in this case your data may be very clustered and no linear shape. Okay.
No,
So
point two in the range 0 to 0.25, you said that it's same line with the negative slope, no?
Same line? No. See, if your correlation coefficient is between this, that this means your data is like this, very clustered and no linear shape.
Okay.
Yeah.
Hmm. Means if it's 0.75 to 1, then there is a linearity that is guaranteed. But if it's less than 0.25, then
Yeah.
this linearity is not guaranteed.
Yeah. If it is 0, and then in that case, that is your data is not linear. It is guaranteed.
Okay. Okay.
Yeah. This means what? If your data is 0, this means what? This means summation xi minus x bar yi minus y bar. See, if your data point are different, then these values are never 0, because these are under root values. Okay.
Yes,
This
sir.
means this value is 0.
Mhm.
This means what? Either your
Numerator
all values are x in 1 point, or all values are y in 1 point. Okay.
Yeah.
Not related.
Yeah. This means like this. Okay. Not related.
Okay, got
Any
it.
other doubt?
No, no, thanks, sir.
Okay. So we can end the session.
Yes, sir.
Yeah. Okay.
Sure, sir. Thank you.
Bye.
Thank you, sir.
Okay.
Thank you for the session, sir.
Thanks. Welcome.
Thank you, sir.
Bye.
Good night, everyone.
Good night.
Good night, sir.